Lesson 1.6, limit properties graphically. We're going to first talk about addition, subtraction, multiplication, division properties, and I went ahead and wrote them out to save the time. So you're probably going to have to pause this and write them out. But what it means is that if I'm finding the limit as x approaches some number of the combined functions f of x plus g of x, basically what I'm doing is I'm splitting that into two limit problems. So I'll find the limit as x approaches a of f of x, and then I'll add that to the limit as x approaches that same a in the g of x function. So that happens for each of these. The subtraction gets split into two limits with subtraction, multiplication, and then division. So you're just separating them into different limits. Kind of reminds me of the properties of logs when we expanded and condensed them. But let's try it on some actual graphs. So here we've got the graph of f, and this is g. On part A, it says find the limit as x approaches 4 of f of x minus g of x. This is so simple, it's almost a waste of time, but this is what they want us to do, is write out the limit as x approaches 4 of f of x minus the limit as x approaches 4 of g of x. So we should get a value for each piece, and then we'll subtract. So let's look at our f graph. Find the limit as x approaches 4. And because there's no plus or minus after it, this is the general limit, so it has to exist. So let's find 4. Okay, even though there's a hole, it looks like when I come from the left and the right, I'm at the same value of -5. And then in g of x, as x approaches 4, I'm at 0. So -5 minus 0 would equal -5. All right, part B, I realized I didn't have a limit value, so let's put in a 2. This is multiplication, so you'll split it up. And the last thing we'll do is we'll multiply our two limit values. Okay, I'll let you go ahead and do this one. Okay, at 2 on f of x, you kind of have to approximate there. So I said 4.3, you could have 4.5, whatever you think. So my answer would get me 8.6. On the delta math, you won't have to guess. This is just because I used a graph and made multiple problems out of it. All right, let's look at part C as we're approaching -7. Split this up first into your two limits. All right, for our f of x function as we're going to -7, I'll call that 3. And then as we're approaching -7 on the g of x, the general limit does not exist because we have a break here. We're coming from the left, we're going down here to -4, and from the right, we're at 1. As soon as you get any part of the evaluating process to be does not exist, then the whole answer when you're trying to do that with something else is does not exist. So if you're adding, subtracting, multiplying, or dividing, one answer of does not exist makes the whole thing does not exist. All right, on the next page we got composition of functions. Here is the rule. When you have f of g of x, I hope you remember doing composition of functions in general, where we would evaluate the inner piece and then plug it into the outer piece. That's what this is saying. So I'm going to take f and say that it's f of the limit as x approaches a of g of x. That's what it becomes. So we're actually evaluating this inner piece first, the limit at x equals a, or x approaches a of g of x, and then we'll find f of that value. But here's a side note that's very important. F of x has to be continuous at that value where you find the limit of g of x. So that's very, very important. Let's try number 2. If I wrote this out, this would be f of the limit as x approaches 8, not infinity, 8 of g of x. So let's find this value first. So looking at g, which is here, this is f, we want to find as x approaches 8. And it looks like our limit would be 2. So then we're finding f of 2. Now let's make sure that f of 2, let's see, f of 2 is right here. we're at -2. And that works because it is continuous there. Okay. Number 3. I'll have that f out in front of the limit as x approaches -8 of g of x. So you're finding this limit for the g function as we're going to -8. It does exist. We're here at 1. So I'm finding f of 1. But if I go over here and look at f of 1, there is a value there, but it's not continuous. That's what this starred note went with. So f of x has to be continuous. There can't be a jump or a break here. We'll talk about discontinuities more coming up, but there can't be a jump or a break. So this is a D&E or an undefined. I can't remember which options they give you as answers. All right, and then we've got exponent property as our last one. Our exponent property says that we'll find the limit as x approaches a of f of x. That will be taken to the nth power. So on this one, we'll have the limit as x approaches 6 of f of x. We'll find a value and we'll take it to the 3rd power. So as we're approaching 6, it looks like our limit is -6. So we would have -6 cubed, which is -216. And then our last one's kind of different. I don't have a name for it, but when you have a limit as x is approaching a number of f of x plus or minus a number, what you need to do is this is your x value. So we're going to plug this in. 5 minus 3 would be 2. We're not going to find f of 2, but we're going to write a new limit where x is approaching 2 of f of x. Okay, so your limit here will become just regular old f of x as x approaches your a plus n, whatever value that is when you plug that in. Okay, so we'll look over here. As x approaches 2, it looks like it does not exist because there is a different left-handed and right-handed limit. So it's D and E anyways.